In this video, we will learn how to calculate refractive index of the material of a solid prism using spectrometer. Usually, in this experiment, students will face two difficulties. The first one is they do not know how to handle spectrometer, and second thing is they find it difficult to calculate for all these spectrometer experiments. For the first difficulty, I couldn't give any fix, but for making the calculation easy, I can give you some tricks and hints. First, let us know few basics that are needed for the calculation. The first basic is the least count. The least count of the spectrometer is 1 minute. Next, let's see how to calculate the total reading taken from the spectrometer instrument. The main scale, if in case the main scale reading is 60 degree and the Vernier coincidence is 14 divisions, then the Vernier scale reading is calculated by Vernier coincidence into the least count. Here the Vernier coincidence is 14 divisions multiplied by 1 minute, that is the least count, so it is 14 minutes. The Vernier scale reading is 14 minutes. So the total reading will be equal to main scale reading plus Vernier scale reading. So the main scale reading is 60 degree plus the Vernier scale reading is 14 minutes. So the total reading will be equal to 60 degree 14 minutes. So this is the formula for all the readings to find the total reading for all the readings. Okay. Next, how to use calculator for these kind of experiments. We do not know, most of the students do not know how to put degree in the calculator. See, I have shown you the three pictures. The first picture you could see degrees and minutes. A finger pointer is shown here. This is the button in the calculator. You can find it in all scientific calculator. When you do a spectrometer calculation, always use a scientific calculator. There will be a button which is used for mentioning degrees and minutes. So if you want to put 60 degree, press 60 followed by this degree button. Then if you wanted to put in the minutes, here I have shown 60 degree and 14 minutes, 60 degree button. Then for 14 minutes, 4 again press the same button. So now we have typed 60 degree 14 minutes in the calculator. So this is how you have to use the calculator for these kind of experiments. Okay, this is the first table to find the angle of the prism A. In each and every table of the spectrometer experiment, you have to mention the least count as 1 minute. See here we have the readings taken from phase 1 and phase 2 from both the Verniers, Vernier 1 and Vernier 2. And before starting the experiment, you have to note down the directory reading which we will be setting, that is 0 degree and 180 degree. So in Vernier 1 it might be 0 degree and Vernier 2 it is 180 degree. So from Vernier 1 for the phase 1 it is 60 degree is the main scale reading, Vernier coincidence is 14 divisions. So the total degree is 60 degree 14 minutes. For the other Vernier it is 240 degree 16 divisions in the Vernier coincidence. So the total reading is 240 degree 16 minutes. Now from the for the reflected ray from the second phase, for Vernier 1 shows 300 degree and Vernier coincidence is 8. Total reading is 300 degree 8 minutes. From Vernier 2, the readings are 120 degree, Vernier coincidence is 9. The total degree is 120 degree 9 minutes. Now we have to find out 2A, that is the difference of the Verniers from readings taken from the phase 1 and phase 2. So look at the first reading, this is 60 degree 14 minutes and the second reading is 300 degree 8 minutes. By looking at the reading itself, we can say the vernier has gone through a one rotation. That means 360, it has gone through a one additional 360 degree. So for the first reading, which is highlighted in the red color, you have to add 360 degrees. Since the vernier has gone on one more rotation, we are adding 360 degree to it. So 360 degree plus 60 degree, 4 minutes will give you 420 degree, 4 minutes. So from that, you have to subtract the reflected ray, the reading corresponding to the reflected ray from the second phase. So it is 420 degree for 10 minutes minus 300 degree, 8 minutes will give you 120 degree, 6 minutes. This is from one phase. I mean, this is for one vernier. For the other vernier, no need to add 360 degree and all. So you have 240 degree, 16 minutes minus 120 degree, 9 minutes. So the answer is 120 degree, 7 minutes. Then mean 2A, you have to add the readings from the two verniers. 120 degree, 6 minutes plus 120 degree, 7 minutes. The divided by 2 will give you 120 degree, 6 minutes. Then half a second will be there. Let's not bother about it. So let's write 120 degree, 6 minutes. For A, you have to divide that by 2. So A will be equal to 60 degree, 3 minutes. Always the angle of the prism will be 60 degree, around 60 degree, because the solid prism which we use during the experiment is an equilateral prism. So all the angles will be same, all the angles will be 60 degree. So the angle of the prism will be 60 degree, 30 minutes. If you are not getting this kind of answer for an for the angle, then you have gone wrong with the experiment, or gone wrong with taking the experiment. Next is angle of minimum deviation. See here, you have two readings corresponding to, one is for the deviated ray, other one is for direct ray. So we know direct ray reading will be 0 degree and 180 degree, and 0 degree vernier coincidence is 4. So it is 0 degree, 4 minutes. 180 degree vernier coincidence is 5. 180 degree, 5 minutes. For the deviated ray, the main scale reading is 42 degree. The vernier coincidence is 11. The total reading is 42 degree, 11 minutes. And for main scale reading, 222 degree from the other vernier and 13 divisions from vernier coincidence. So the total reading is 222 degree, 13 minutes. So to get D, the angle of minimum deviation, let us subtract the deviated ray reading and the direct ray reading. From the vernier one, we are getting 42 degree, 11 minutes minus 0 degree, 4 minutes gives you 42 degree, 7 minutes. And from vernier to 222 degree, 13 minutes minus 180 degree, 5 minutes gives us 42 degree, 8 minutes. So from the deviated ray reading from vernier 1 and vernier 2 are almost the same, 42 degree 7 minutes and 42 degree 8 minutes. Let us take the mean for it. Adding these two and dividing by 2, you will get 42 degree 7 minutes and then half a second, which let's not take it into account. So it is 42 degree 7 minutes. Now let us calculate mu. So A here is 60 degree 30 minutes, D is 42 degree 7 minutes. The formula goes like this: mu is equal to sin A plus D by 2, sin A by 2. Let us substitute the value of A and D. Then we will get sin 30 degree 3 minutes plus 42 degree 7 minutes divided by 2, sin 60 degree 3 minutes divided by 2. So adding this A plus D will give 102 degree 10 minutes by 2 and 60 degree 3 minutes by 2. Then do 102 degree divided by 10 minutes divided by 2, you will get sin 51 degree 5 minutes and sin 30 degree 1 minute. So in the scientific calculator, find out the value for sin 51 degree 5 minutes. You will get 0.7780 divided by 0.5003, which will yield 1.555. So the refractive index of the material of the solid prism is 1.555. Usually the solid prisms are made out of flint glass or crown glass, where the refractive index will vary from 1.5 to 1.6. So if we get 1.5, the values closer to 1.5 to 1.6, then you have got a correct answer. If you are getting 1.4, 1.3 or 1.7, it is not an right value for the material of the, I mean refractive index of the material of the solid prism which is used during the experiment.